All right, welcome to another episode of Bitcoin Smart Contract, and I'm glad we have more people coming. So for newcomers, welcome here. And again, I want to make this more interactive. So if you have any questions, just raise your hand or feel free to interrupt me at any time. Okay, so just have a brief recap. I think in the last session we announced this. We call it script TS. So basically, is instead of using a totally new language, for example, script or even Bitcoin script to write smart contract on Bitcoin. So we introduced this new framework that enables you just to write everything in TypeScript. So you don't have to know anything about, other languages. My hope is, as more people that are coming from, JavaScript / TypeScript, background, so they'll be more comfortable. So they can reuse. So they don't have to learn a new language. Also, they don't have to learn like all new tools. So all the existing tools like IDEs and also NPM, they can use exactly the same tool. Okay. So we cover a little bit of, the basic syntax, for example, different types, and also how do you define your customer functions, and also how do you make sure, when you can have something that once you publish, other people, external transactions can call this so-called public transactions, and you make sure all the assertions pass, and then only then your contract call is deemed successful. So if all the assertions pass, you're good. So we also talk about a little bit of syntax-wise as constructor, and this is like a hello world smart contract we showed last time, and which is if you're coming from JavaScript / TypeScript, hopefully this is a very intuitive and readable to you. So today I'm going to just keep this series to cover more syntax and also some of the more domain specific things that when you write a smart contract using script TS. So
may I ask one question right now?
Sure, go ahead.
Before I forget it, before we dive into the details, I remember that JavaScript is known for being not very performance and secure language. So does this framework have some issues with being somewhere less secure than script or less performant, or it's has the same security and performance and we have no downsides of using it versus the script itself?
Yeah, great question. Short answer is the same security and same performance. Why? Because you can think of both. This script TS and also script is like syntax sure, right? Because eventually everything will be down to so-called Bitcoin script, which is run by miners. So I think performance, because it boils down to the same thing, right? So performance is the same. And then in terms of security, that's why, when I say, JavaScript / TypeScript. So if you look at syntax here, actually here is strictly TypeScript when you write this contract. So you can have more type safety. So in this aspect, it's also, I would say is, if not the same, is at least similar to script in terms of the type safety. Make sense?
Okay.
Okay, great question. Any other question, comments? Okay, if not, let's move on. So the first thing I want to just highlight a little bit. So in the last session we talked about it has script TS had three primitive basic types. Boolean, big integer, not number here, big integer, and also string. So string you can think about as, if you're coming from a script script is equivalent to bytes. It's just a byte array. So you can have two ways to using to write literals in this session. The first one is, if you want to use hello world, like a second line, you can use it's just pretty much like UTF-8 encoded, byte string. Or a lot of times in our case, because you want to have some, have the string in hex format, hexadecimal format, right? So we provide almost like a built-in function called B. So if you put the string inside B, it's going to be regarded as a hex string. So for example, you want to say, hey, I want to put FFE, the hex number, into the A. That's how you're going to write it. Versus here, you only put the double quotes or single quote, whatever your favorite style is. It's going to be like a literal UTF-8 encoded string. So for the string, and because in our case, it's pretty much regarded as a byte array. So not everything, the regular TypeScript string function you can call. So for example, here, right now, we only support 2 operations. One is concatenation. You can use just a plus sign to concatenate 2 strings. And the other one is slice. So basically, you can get a substring of this string, let's say called B. So you can say from 0 and then to 3, but does not include 3. So for anybody who has probably seen, slice in JavaScript or TypeScript before, this should be straightforward. Any question here? Okay. Yeah, if not, just keep going. So this is string type. And then the next is, because we want to provide more type security. For example, you can have all kinds of strings, right? You can think of, you may have public keys, you may have signatures. What if I want to have a function, the parameter has to be a public key, but accidentally, right? By mistake, I can pass in a signature because both are strings, right? To avoid this type of mistakes, we add more refined types. Think of in the Bitcoin space, right? So this is not the basic types that's come by default with TypeScript. These are the types we add. So all of them you can think of, they're all byte strings, but they're more specific. So for example, I just mentioned 2, right? You can have the public key, type. You can have a signature type, but you can also have all kinds of, for example, public hash. So for people who've not heard about, who've heard about Bitcoin address, so it's actually taking a public key and hash it using this RepMD 160 hash. So you can think of this is an alias for this hash. So, Bitcoin not only have this hash by default, they also, of course, from the famous, most popular use, I think, SHA-256, right? That's used in mining, but also when you compute the address. So this is another subtype, and you also have this SHA-1 cousin called SHA-1 here. So these are the major domain types we'll be using mostly to increase the type safety for the framework. So how do you use these types? I just give one example here using public key. So you can pass a string here to construct a new public key type, and then once you have the public key type, you can also convert it back to native string type by causing all of this has this function called toString. So you can use in new, you can convert from a string to the domain types, and then if you call toString on the domain types, you can get back to string. I'm going to pause a little bit here, and any questions so far? This is good. Okay, I assume it's good. So let's move on. So I just showed you, different domain types. So here I'm just showing you one, example smart contract here. So for people who have missed, who just started this course today. So basically, again, it's very easy to define a smart contract. You basically extend a smart contract from script TS. So for example, here, what we're looking at is so-called pay to public key hash. So anybody who have not heard about this term before? Pay to public hash? Anyone? Who have not heard about it? Okay, great. That's you guys are all Bitcoin veterans. So for people who have not heard about the pay to public hash, basically when you send a so-called normal payment, Bitcoin payment from Alice to Bob, so this actually run this contract called a pay to public hash. So why is called so? Because in order to unlock, for Bob to unlock the money you just received, he has to pass. So in the address,
actually doesn't have coconut milk in it. Tomka guy has
You want
coconut.
me to take that and then put it in a. Then is this formula?
hello? I think somebody is not muted.
The water, and then
Mike.
Oh, sorry.
Okay, no problem. Okay, so I thought you have a question about pay to public hash, but anyway, keep going. So, so in Bitcoin address, this is so-called pay to public hash contract. Why? Because the address is, as I talked earlier, is pretty much just a hash of the public key. So in order to unlock this kind of a contract, you have to provide two arguments. One is, the public key itself. The second is the signature, right? So then the smart contract will check two things. First, does the public key hash to the address, here, denoted here, right? This is a property called public hash. And then first, make sure the public hash is actually hashes to the, address. And second is the signature value by calling this check sig. So this is how you write the most popular smart contract used today, pay to public hash, in using this TypeScript framework. So again, here you have properties. This is the public hash. You can call constructor. Of course, again, the first statement has to call the super and with all the parameters passing, and then you can initialize here. And then this is the public method. Basically, this can be called when you're trying to when you try to call the contract methods. So you can call it unlock. It has two parameters. One is the signature of sig type, and the other is public key of public key type we just talked about. So you can hash it and you can compare it. And then you do make sure that signature checking. This is also a built-in function for any contract from here. So you can call it check sig. So if both this assertion pass, that means you are authorized to move the coins. Any thoughts, comments here? This is pretty straightforward. Okay, so let me ask you guys a question here. So, if you look at here, when I do the hash and I compare with this hash, I did not just use the equate operator here. Why do I have to convert it first back to string here? And anybody has a guess? Why not just
object? It's a complex object.
Yeah, great question. Yeah, great answer. Yes, exactly. Because the public key hash is this object type, right? It's not a primitive type. So, the one big difference of TypeScript with a lot of other mainstream language, static compile, it doesn't allow us to overload the operator. So if in Python or C++, if you can overload this equal operator, you can overload on the type of this specific class, right? But unfortunately, in TypeScript, this is not allowed. So that's why you have to convert it back to the primitive type before you can use the equation mark here. Yeah, great answer. Anything else here? Okay, let's move on. And this is the first, I would say, if you're coming from pure TypeScript, this is maybe a little bit of attention you have to pay here. So we have to do loops, right? So for all the major languages, you have to, for the control flow, right? Usually you have a conditional. We don't have to talk about that because it's just TypeScript. So you can use if else, whatever you like. that's exactly the same. The only difference here is when we talk about the loops, you have to be careful. So the short answer is you cannot write any kind of loops in the smart contract. Why? Because if you talk about Bitcoin, right? So eventually it boils down to so-called Bitcoin script. So everything has to be so-called unrolled. The loops have to be unrolled at compile time. So that means we have to know how many loops it's going to be. So if you use something like a while loop, a do while loop, we cannot figure out that the compiler cannot figure out how many loops you're going to have. So that's why we only have support only one type of loops, the for loop, and also it has to be this form. Have to be for let I equals. It has to start from 0, and then it has to be strictly less than some number, and this number has to be known at compile time. So for example, it can just be a number literal, right? So 5. Or you can define it as you have 3 ways to define this upper bound here. One is just use a literal here, right? That's 5. Or you can define a constant number. You can put it here. That's another way. Or you can if in TypeScript, right, you can also define almost like another way to define like a read only. Put it here. You can also put it here. So this is the only type of loops that's allowed in a smart contract in our framework.
I have a question here.
Yeah, go ahead.
So this number can be as large as max integer number, correct?
It can be as big as you want. So actually it's a big int actually. You can convert it to arbitrary big number if you want.
And the fees for this contract will be as large as this number, or it's indirect dependency?
The fees, you mean?
Yeah. So, for example, if I have exactly the same code, but let's imagine that the loops will always take like 5 iteration, but I will change the number from 5 to like 10,000. Will it cost more to execute such contract?
At the moment, yes, it will cost more. Reason is, as I said, eventually it's going to be unrolled into Bitcoin script, right? So let's say you have 5 loops, you're going to repeat that whatever the body of the for statement 5 times, right? It's going to be flattened, unrolled, so-called. If it's 5,000, it's going to be 5,000 times. So the bigger the script, the bigger the transaction, and because the miners now charged based on the size of transaction, you have to pay more fees. So it's pretty much proportional to the number of loops you have.
So it's like not directly transpiling the code I write, because, for example, if I have 10,000 as number of iteration, but on the 5 iteration I do break, so it would only take 5 iteration in TypeScript, but in script it would take 10,000.
Yes, because it's the miners, they only look at right now they only look at how big the script is, right? They don't know, they care. Oh, if 1,000, but turns out I break after 5 iterations. The miners, they don't check right now. They just look at the raw size. So I could imagine, in the future, the more smart contract gets deployed, and the miners, if they're intelligent, they probably should do like, if you only run 5 times, you should charge based on 5 times, not 1,000 times, right? Because that's the upper bound. That's not the actual computation the miners has to compute. But right now they only do like based on the size. So yes, if you have the upper bound at 1,000, and you turns out you break out at 5, they still charge 1,000 full price.
Okay, thanks. Got it.
Thank you. Yeah, I think this is for people just using normal TypeScript. This is maybe a little bit of a surprise to you. So, any questions and comments here? More?
Yes, actually. So I remember watching the previous demonstrations, And you mentioned about running code to do some calculations outside of the so-called script functions. So is
Yes.
it possible to run certain loops on the functionality to provide the returned response or returned value to run loops based on and breaking those, for example, breaking a loop at a certain iteration and then providing that returned value back into the script function?
So let me guess, you correct me if I'm wrong. So basically last time we talked about, the reason we add this decorator is because we want to allow non-smart contract inside the so-called smart contract class, right? So you can, for example, here you can say, oh, I want to compute hypothetically, right, a Fibonacci sequence, right? But this is not going to deploy on chain. You can write let's say just a normal function here without this method. You can put there, you can write arbitrary types of loops. You can use while loops, for, do while, for, and also because it's not going to be end up in the Bitcoin script deployed on chain. So there's no constraint. For example, you just mentioned, right? I can compute the 1000th Fibonacci sequence. There, I can break out. And then that code is only going to, it's like that part is normal, like a TypeScript. It's real TypeScript. So there's no constraint there. Is this what you're trying to ask?
Yeah, correct. So just thinking in terms of, keeping the size down, if there's a lot of loops, you could run the looping function separated from the script methods.
Yes, that's a very popular technique to actually optimize the size of the contract. For example, right, for people who have like modular arithmetic, right? For example, you have you want to do a modular inverse, right? You want to compute, hey, what's 5? The inverse of 5 modular, let's say 10 to the power, 100 or something, right? Huge number. If you do the normal modular inverse division, it's going to cost you huge. It's very complex. Or if you do like a matrix inverse, right? You want to inverse a matrix in a smart contract, it's going to be very complex, right? For example, you want to inverse like 1000 by 1000. In a very good trick is what you just hinted is, I can compute the result, outside, in this sense, I can put, some other method here or here, which is not, so for example, function here or here, I can compute it and then pass it in the, method decorator. Inside, I only have to check whether it's good, right? For example, the modular inverse, I want to compute the x inverse. I can just pass a y and make sure x times y equals 1 modulus, right? Then it's only like pretty much like 1 or 2 opcode. Or the matrix, right? I can pass A, I can pass another matrix B. Inside, I only do the matrix multiplication. Make sure it gives me the identity matrix, right? So that's a very common trick we can play if you want to optimize a smart contract. But that's like more advanced. I think probably we can cover more later. But yeah, good point. So again, here only applies to functions that's declared with method, because that's the part. Only this kind of things, they're eventually going to go to the Bitcoin script and will be in the transactions put on chain. So the constraints for loops here, that's only applies in this context. For outside, it's not going to end that chain, so you can use any kind of loops you want. Is it clear?
Yes, thank you.
Okay, great. Any other questions here? Okay, if not, we can keep moving. So another, I would say, because that for script.ts, you can think about it like a domain specific language, right? So it is TypeScript, but it's a subset. So I just mentioned one restriction, for loops, and you have a special type of for loops. And the other one is, arrays. again, because of everything has to be known as static time, kind of compile time. So arrays, for our arrays, you have to use, everything has to be fixed length. So we have this built-in types coming from this framework called a fixed arrays. And the first one, is a generic type. So you can instantiate with first one is what's the element type, for example, big int, and what's the size. So you cannot use the normal, any arbitrary arrays. If you want to use array, you have to use this fixed array in our case. So you can have a one-dimensional, of course, you can have a two-dimensional, and then you can also initialize it with a array syntax like this. So short answer, for anything that's array, you have to use fixed arrays in our framework. Make sense? You cannot use a dynamic array. So for example, you cannot say declare array length unknown and compile time, and then you can push and pop. That's not allowed.
So if I will try to use normal array, it will not compile, or what will happen?
It will not compile. So basically, it's the same thing. You can try it here. It's like here, right? If you put let's say a variable that's not known, for example, you can put like an input number here, right? So x, you say I smaller than x. When the transpile start kicking, it will report an error. Same here. If you use a normal array, not using fixed array, it will give you the error message saying, oh, this is not allowed in a smart contract context. But you can use outside, that's no problem. But only when I say smart contract context, I pretty much mean it's not allowed in anywhere that has the decorators. So for example, you cannot use here, you cannot. But outside, maybe you declare a function, normal function, you can use it there, or here, but inside the method, you cannot use it. It will report error. You can try, yeah.
Okay, thanks.
Yeah, good point. Yeah, for anything that's not allowed, I just covered, it will report compile time error. Okay. So talk about the customer types, right? Array is one type, another one, of course, everybody wants to define their own types, right? For a lot of good reasons. So it's so-called a structure. How do you define a structure in our case? Because this is a TypeScript, so we support two ways you can declare your customer type. One is just using type keyword. For example, I can define a structure consists of two fields, A and B. And A is a big int type and B is Boolean type. Or these two are equivalent. So whatever style you want. You can also use the interface syntax to define another structure. For example, you can have a two-member XY. So, but they can also be embedded within each other. So for example, here, Y is a string type, is a basic type, but then X is a customer type that I just defined before. So short summary, you can define your own struct using either of this syntax here. It's equivalent. And all the members, at the lowest level, eventually it's going to be one of the three types, we support. So you cannot say, for example, here, you cannot use a type, say A, for example, number. That's not allowed. It has to be one of the three basic types at the leaf, at the lowest level. Okay. Any question here? Okay, that's good. Let's keep moving. Seems this is straightforward. And console logs. Okay. So I just talk about the different statements, right? So we talk about how do you do loops? Use the special for loop syntax. And if conditional is the same with a normal TypeScript, and I just talk about, and here's the thing, for TypeScript built-in functions or types, or classes, almost all of them you cannot use them by default in script TS environment, except a few cases. And console log is one such exception. So for example, here this is the method we have seen before. You can add two big numbers, big ints. So if you put a normal, for example, built-in functions here from TypeScript, it's not going to recognize it. It will report a compile time error. There are a few exceptions, and one of the most important thing is this console log, because we want to enable you to debug it, right? Or print all kinds of auxiliary informations when you are debugging the program. So we make one exception here is console log you can use in smart contract environment. It's going to print out whatever value you print out. But eventually, because in Bitcoin script, right, in Bitcoin environment, the miners, they are not going to, when you send them transaction, they are not give you a console log back, right? So the trick here is eventually when you compile down to Bitcoin script, this is going to be ignored. So this is only for debug purpose. Make sense? So it has a whitelist. Almost everything is blacklist, except some things in the whitelist. And one of the number one things in the whitelist for building functions is console log to help you to debug.
Yeah,
Any question here? Mm-hmm. Okay. Yeah, seems okay. You guys got it, because this is more, it's like convenience, right? You can maybe debug it some other way, but a lot of people, especially if it's a small program, they just want to do something hands-on, handy, like a console log. They probably don't want to launch the debugger. Oh, which is, by the way, I'm going to show you guys how to use the debugger next week. So this week, if you want to debug something, console log is your friend. Okay.
Does the debugger require the paid version of the extension for Visual Studio Code? Or?
No, this is totally different from script. This is just TypeScript. So you just use Visual Studio Code or whatever your favorite IDE is. Think about now, forget about script. There's only TypeScript here.
Okay.
So you don't have to pay for anything. Yeah. Even for script version, the basic debugger is also free. Just FYI. It's just only the advanced version of debugger, which you can look at the assembly level code. But most people don't look at it, but don't need that. So it's also, that is also free, the basic version. Comes with a debugger also. For this one, it's entirely free because it's just Visual Studio Code or Eclipse, whatever your favorite IDE is, Atom, you can use it. This is just TypeScript. That's a key point. Forget about script, Bitcoin script. There's no such concept here. From now on, it's just TypeScript. Okay. All right. So that's pretty much what you can, what kind of things you have to master in order to write a so-called smart contract using our TypeScript framework. So once it's like any standard software workflow, right? So once you finish a piece of code, you want to test it, right? So we also have the framework also coming with testing support, out of the box. So for example, here, we just use, for example, if you want to test the so-called demo contract we showed earlier, the demo contract, it has a built-in, it has a public function that you can add two numbers or you can subtract two numbers. So we are going to, how do you test a smart contract? So you can also use our framework, which is also very straightforward. You can use it combined with any testing framework, your favorite testing framework. For example, here, I just show examples, we just use a so-called Mocha plus with Chai assertion framework. So you can use any other, your favorite, but I just use the Mocha here as an example. So, use it for anybody Anybody who have not heard of a Mocha, who have not used Mocha before? Here, anyone? Okay, great. So you guys are okay. TypeScript, JavaScript gurus here, so I don't have to talk too much. So if you look at here, this code is for anybody who has write unit tests in TypeScript/JavaScript. So this is very readable. So pretty much before it's just you can think about the setup phase before any of the actual test runs. So the standard way is here. Before you test any smart contract here, you have to compile it. So pretty much this is what the name suggests. It's like a one-time only setup. That pretty much just compile whatever smart contract you have in this example demo down to internally to so-called lowest level Bitcoin script. But you don't have to know all the detail. But just remember, before you run any test, when you set up, you run this one time. So think about it as a initialization. You compile, you do it this one time, and then forget about it. And you don't have to know what it's doing here. But pretty much you can think of a one-time setup. So once you have this, then you can treat this as a normal, class. So you can call it constructor. You can do a demo contract instance here. So once you have the instance, you call this function called for local testing. You call verify. So what does this do? You pretty much just as the name suggests, it just call the function by call some public function of this smart contract. For example, we say add, right? So if you remember what the demo contract does, let me show it quickly again, just to refresh. So this is the demo contract we had before. So you put initialize with 2 numbers, and then you're going to assert whether the argument you pass in is equal to the sum of these 2 numbers. So in this case, when you are testing, because we initialize it with x equal to 1 and y equal to 2. So not surprise, right? So when you say add 3, this is going to call the public function, and the verify is just give you return a result. So the result has is a struct, has 2 fields. One is success, whether it's success or not. The other is the error message. So if it's not success, it will give you an error message. So if you already know the Chai framework, the library, this is how you write pretty much how do you expect what's the result is going to look like? Because this is 3, so we expect this to be true, right? Because 1 plus 2 is 3. So same here, you call this public function and you put this under the verify function. So because 1 minus 2 is minus 1. So we are also expecting this to be true. So the only, I think a little bit of a note here. So here, remember here, the verify takes a function. The verify function takes, if you so-called here, it doesn't take the result of the add because it's a public function, right? It doesn't return anything. So it actually takes a so-called lambda function. So the lambda functions you have to write in this way. So that's the only thing you have to, it's a little bit of paper, not exactly what you expect. Because the only reason we do it here, because the add doesn't return anything, right? Because it's a public function. So if you look at all the public functions, so it's return voice. So there's no return type value. So that's the only way, that's the only reason we have to wrap it in a lambda function. Okay, I think there's a lot of information here to unpack. Any questions? Anybody wants to get started? Oh, this is very straightforward. It's good?
I would say not very straightforward, but the question will probably arise when we start doing some homework.
Oh, you are reading my slides. Okay, I don't know how you get this kind of superpower, but yes, you do have homework for today. So from today on, it's going to be very hands-on. So that's why I want to give you some, hands-on experience, because, you can hear me talk about it, as you said, right? But, devil is always in the details. It's great. It's going to be, when you play with it, that's how you can learn it best. So for today's homework, I'm going to leave you 2 tutorials. One is walk through the hello world. Basically ask you to set up and then write the hello world smart contract using our framework. And then the next, once you have the smart contract ready, hello world, you're going to write a test against it. So these 2 are the homework. So, hopefully by next week we meet again, you guys are finished these 2. And in the meantime, we have a Slack channel support group. So anytime you have any issues, you can find me over there. So again, as last time, this is the URL that you can find all the tutorials and all the documentations, examples. Just go to here. You can find the 2 tutorials I just mentioned. For this homework, let's walk through the first 2 tutorials.
Will
Okay.
you send some email to all participants?
With this link?
Homework.
Oh, just walk through these two tutorials. If you go to this link, let me actually go to this link right now. So this is the, I don't know which screen you are seeing. Let me share it again. Can you see my screen?
This is the presentation and browser.
Are you seeing the browser version or no?
No.
You're seeing the
Browser and presentation.
Oh, let me
Just
share
see
it
the
again.
presentation, yeah.
We're still seeing the presentation. Okay, let me share it again. How about now?
Now
Yes,
we see the
yes.
browser.
Okay, great. So this is the the URL I just showed. So you can just click tutorials. So we have a lot of documentation here. How do you install it, how to write, how to test, debug, deploy. Where for the first homework, I want you guys to finish these 2. One is a hello world. So basically I have you to set up the environment and how to write a basic smart contract from empty to the full contract. So once you have that, you are going to walk through the second one to teach you how to write the contract, the test I just mentioned. Make sense?
Yeah.
Okay, great. Any other question before we wrap up? That's all good. All right, sounds good. Hope to see you next week. Okay, remember to finish the homework, please. Okay. All right. Have a good day,
Okay.
everybody. Thank you for coming. Thank you. Bye-bye.
Thanks,
See you
bye.
next
you.
week. Okay, thank you.
Bye.
Have a good one. Bye-bye.
Bye.
Bye-bye.
Thank you.
Have a good one.